Hello and welcome. In this video, we're going to look at parallel power. So we have a couple of expectations over here. We remember that the voltage remains the same in parallel and that the current is the dividing part in parallel, which is meaning that the power is going to do a lot like it did in series. Power distributed in series, well, power is also going to distribute in parallel. But this time, instead of it following the voltage drop in series, it's going to follow the current divide in parallel. And so in this circuit here, they've given us a 6-volt source, a total current of 24 milliamps, and a P2 power value, which is the power across the R2 resistor, of 64.5 milliwatts. And they want us to find P1, the power across the other resistor there, R1. And so we can use what we expect from this circuit. We expect the current and the voltage to equal our power total. So we can say PT is equal to our IT multiplied by our voltage source. We're given both of those two values here. And on top of that, we can say that once we find our PT, it will also apply our KCL understanding. We can say that the PT minus the P2 is going to give us whatever is left over in the circuit, P1. Right? So we can reduce that down and solve for that. So we need to multiply our total current and our voltage source, and then use that to find our P1 power value. So here we can say that we have 6 volts multiplied by, and we've got 24 milliamps for our circuit. And if I just leave that at 24, since our 6 volts is at base, our 24, leaving it just like that, will give us a milliwatt value, right? I can plug them all in and get a really small wattage value, or I can say, well, the milliamps is going to transfer over to be a milliwatt output. So this is going to give us 144 milliwatts. We can use that in our total power. We can say that P1 is equal to 144 milliwatts, that's our total power, minus what we were given for P2, 46.5 milliwatts. Since they're both in milliwatts, we don't have to account for those. We just know that the answer is also going to be in milliwatts. So we'll say 144 minus 46.5, that gets us 97. So P1 is equal to 97.5 milliwatts. So this tells us that R1 resistor is probably the larger of those two resistors. It consumed way more voltage and it consumed way more power than the R2 resistor. All right, let us know if you have any questions.